Welcome to the Bentley Systems training course where we will show you how to design concrete structures using the STAAD Advanced Concrete Design RCDC method. Through this process, we will show you how to design your concrete beams, your concrete walls and columns, as well as your concrete slabs. In this first video, we are going to be focusing on the design of our concrete beams. To begin our workflow for designing our concrete beams in the STAAD Pro Advanced Concrete Designer RCDC, we're first going to model our structure in STAAD Pro and then perform the analysis. An analysis in STAAD Pro must be performed before importing any of the model elements into the RCDC. To do this, we're going to click Analyze followed by Run Analysis. Now after the analysis is performed, the model is closed and then imported in the STAAD Advanced Concrete Designer, we're going to see that all the model information will be available once it is imported. This will include all of the properties, specifications, supports, loads, materials, and analysis data. After the model is complete, we're going to stay in the modeling mode and click Done, and then we're going to exit out of STAAD Pro. After the model is closed, we are then able to import the model into the STAAD Advanced Concrete Designer RCDC. To do this, we're going to double click on the icon on our desktop. And then begin the process of creating a new project. We're going to enter all of our project, client, and engineer data, and then we're going to enter our design code. For this training, we're going to use the ACI 318-211 code, and we're going to use the metric version of this code. Then we're going to select our STAAD Pro file. We're going to use our Browse button and select our file that we just analyzed. After it finds the file, we'll have the option to import the pile caps, footings, columns and wall data, beams or slabs, and we're going to select the beams for this exercise. Next, we're going to select the level we want to design. So it'll detect areas of horizontal beams, and we'll go ahead and select the level at 2 meters. Finally, we'll complete this process by clicking the Create New Project button. Once the file is created, all of our beams at that particular level will be imported. We're going to see that we have two main tabs available right now. We have our Design Grouping tab, and what you'll notice is that the concrete beams have been transferred into the STAAD Advanced Concrete Designer successfully. All of the concrete beam sizes that were specified in STAAD Pro have also been imported. In addition to that, we also have a Beam Continuum tab. You're going to notice that STAAD Advanced Concrete Design RCDC will identify the continuous beams, and it will group continuous beams to be designed and detailed together. And here we can select each of the beams, and they'll be highlighted in the main window. Before performing the design in the STAAD Pro Advanced Concrete Designer, we are first going to set up our basic load cases and load combinations. In your Settings menu, you are going to select Basic Load Cases. And what you're going to notice is all of the load cases that you defined and analyzed in STAAD Pro have successfully come over into the RCDC. Before accepting these load cases, we need to specify the appropriate load types. For this model, we have some seismic load in the 2 horizontal directions, and also some dead load, live load, and roof live load. After you specify the load types, we're going to highlight all of the load cases and move them over to the selected area. Once we're done, we'll go ahead and click OK, and then the program is going to ask us to define our load combinations. For this operation, we're going to add from the template, and we're going to select regular structures. And here we'll be able to preview all of the load combinations that will be created. Once we're done, we'll go ahead and click OK, and then we'll save our model. Next, we are going to work our way through the rest of the concrete beam settings before performing the design. We're going to go to the menu bar item for settings, and then we're going to start with the general and reinforcement settings. Here we're going to set up some general pieces of information. The first checkbox we have is to ignore torsion. Torsion in beams that is less than the value that is set in this dialog can be ignored. We also have an option for ductile design. Now you can select this if a frame is a special moment frame or an intermediate moment frame. And next we have a flanged beam checkbox. Beams can be designed as flanged T or L sections. Slabs designed in the STAAD Advanced Concrete Design RCDC can be imported to get the flanged action. We can also set some detailing style settings and some percentage of reinforcement settings as well. After that, we can set up our material properties. Here we're going to use C20 for our concrete grade, and for our steel grade, we're going to use the FY420. Lastly, we can end up setting some rebar settings, and here you would set the rebar types that you would like to be considered for optimization in the design of your concrete beams. Once you are satisfied with all your general and reinforcement settings, you will go ahead and click OK, and then we're going to proceed to the next group of settings. So we're going to return back to our settings menu bar item and work our way down. This time we're going to select rebar curtailment. Here you can specify the top and bottom steel curtailment location, which would be the preferred curtailment location for top steel at ends and continuous supports as a fraction of the effective length. You can also enter your shear zones for ductile beams and for non-ductile beams. Once you are satisfied with your curtailment settings, you will go ahead and click OK. Next, we're going to specify our detail and drawing settings. Here you can specify your rebar anchorage, your secondary beam end anchorage, rebar couplers if required, and dimensions, and finally your effective span for curtailment. Once you've specified all your detailing and detail settings, we'll go ahead and click OK. And the last piece under the settings menu bar that we're going to take a look at today is the preferred bar spacing. Here you can enter your preferred bar spacing for each type of beam that you've imported into the model. And as a reminder, the STAAD Pro Advanced Concrete Designer RCDC will import your beam properties from your STAAD Pro model that's already been analyzed. Once you're satisfied with your preferred rebar spacings, we'll go ahead and click OK, and then we'll save our model before going any further. We are now ready to design the concrete beams in this model. Up in our toolbar, we're going to click on the Auto Design icon. The STAAD Advanced Concrete Designer RCDC will design the beams for the combined effects of flexure, shear, and torsion. Each section is designed for each individual load combination to arrive at required areas of longitudinal reinforcement at the top and bottom and shear reinforcement. Shear due to torsion is also computed. The STAAD Advanced Concrete Designer RCDC will automatically look for continuous beam members in the STAAD model and group these as single physical members. Once the design is complete, we can see each beam design group has been provided. We can see the material properties and sizes assigned to each, and then we can review the reinforcement for the top and bottom and also the shear reinforcement. If any of the beams fail, we would be able to identify that by clicking Reports, followed by Failure Diagnostics. For this particular model, none of our beams have failed. In addition to seeing that, we would also see this bar over at the left-hand side turn red if there were any failed beams. After the beams are designed, you can review the design of each individual beam group, as well as modify the reinforcement as required. In the design tab, we're going to highlight one of our beam design groups. We'll highlight G1, and then we'll try to modify our design. We will click Modify, followed by Design. Here at the bottom of the page, we're going to see our Redesign Group 1 become available. Here we can review a lot of the properties such as the size of the member and the reinforcement that was provided. We can also modify the concrete grade, steel reinforcement, and clear bar cover. Once you review this information, you can go ahead and click the Cancel button. Now, if you wish to modify the detailing of that particular design group, we can return back up to our Modify menu bar item and then select the Detail option. We're still selecting Beam Design Group number 1, and here we can see the reinforcement that it was provided. Now, for each of these areas, we can select a particular area to redetail. Say, for example, I want to redetail the top bars. I can double click on the top bar, and then the top steel dialog will appear on my screen. Here I can modify the reinforcement as required. Now, if I wish to generate a beam schedule or drawing, I would go up to the Reports menu bar item, and then select Text Schedule. Here I can select two different schedule types. I'm going to select Type 1, and I'm going to group my beams. And here you can see a CAD style schedule has appeared on my screen. In addition to that, I can also view an elevation. I'm going to go back up to my Reports menu bar item, and then I'm going to select Elevation and Section. Here I can select any beam in the model. I'm going to stick with my design group number 1, and I'm going to draw an elevation and a cross section. And here you can see I have a CAD drawing of the elevation of the particular beam I selected, as well as a cross section. Lastly, we're going to take a look at the Bill of Quantities. Back up in my Reports menu, I'm going to select Bill of Quantities, and I'm going to select a Bill of Quantity Summary, and then we'll click OK. And here I can get my bill of materials where I can see how much concrete we'll be using and how many of each bar size we will be using as well. The last step in our workflow is to generate the beam design calculation. Up in our Reports menu bar item, we're now going to select Design Summary. And here we can see a beam design summary for each beam design group. In addition to that, if you require fuller calculations, you can go up to your Reports menu and then select Design Calculations. Here we'll select Beam 1 or Beam Group 1. And within this table, we'll be able to see the longitudinal reinforcement results, the transverse shear results, and the maximum spacing and skin reinforcement. This concludes our process for designing reinforced concrete beams in the STAAD Pro Advanced Concrete Designer, the RCDC.